Hello everyone, this is Mohammad Assadujaman Jabin. Today I am going to present our class homework on MNIST Handwritten digit classification using deep learning. So the goal of this homework is to run the basic train of deep learning models and find the most feasible hyperparameters. So this task could be divided into two subtasks. One is the find the feasible learning rate and activation and optimizer function and choose the best epoch size. And the second one is load the other data set like Excel or the image to check the accuracy and save the predicted result in CSV. So, and the second task is we need to change the optimizer function and that we test with our best model and do all the things of subtask 1. So let's dive into the code. The first part I just started with loading the packages from the libraries like import NumPy, Panda, PyPlot, and Keras, TensorFlow, and the sequential models, and also dense dropout activation function and other things. And then I just load the data set. This is the code for loading the data set. So just MNIST data set, it is already in the TensorFlow package. So then after loading the data set, it just directly load the image data set and then just check the shape of the train and test sets. So these are the 60,000 images, 28 by 28 pixel data, and the test image is 10,000, and both are the same size, 28 by 28. And then I also load the other data set as CSV image file from other Kaggle resources to test my model. So later I will show how I test my model. So this is the test CSV file. So I already import the data here. And next it's time for data processing. So at first I need to reshape the data to 784. So it's the multiplication of 28 by 28 pixel. So load just train and test sets. And then I have to convert it to the float type because it's an integer, and I'm going to normalize, and normalized output could be like a double or floating point number. So just convert this into a floating point number, and then to normalize, I just divide this one into 255 because each RGB value was zero from 0 to 255. So just convert the RGB image into grayscale image, and then check the shape, and the shape is almost the same. And then since we have 10 digits, 0 to 9, so we have just 10 classes. So just convert each and every level into into a numerical data. To convert this one into numerical data, we just have to use two categorical. So it's a way to convert the label into a categorical data. And then it's time for build a neural network. So my model is a simple, fully connected feed-forward network. So it's basically, it has 3 layers. So you can say it as a shallow network. So it's a fully connected. So the input number of nodes is 512, and the input size is 784 as usual, 28 by 28. So in first layer, I just use dense 512, and activation function is relu. And after second layer, I just use like a 20% dropout of these 512 nodes. And then in second layer, same dense 512, and the activation function is relu. And then again 20% dropout. Dropout is mainly used for to minimize the load on each and every nodes into the layer. So it actually helps to increase the performance of the system and also get the better accuracy, and it also helps to helps the model to regularize for the new data without overfitting. And the last layer, I use dense 10 10 nodes because should be the similar to the number of outputs. So we have 10 class, so the dense 10 is for 10 node, 10 classes. And since it's a categorical model, 10 class classification problem. So we have to use softmax as the activation function for the last layer. So let's see about the detail. This is the detail of my model. So if you want to show the graphical representation of the data flow, so this is the graphical representation of the my data flow. So the first task is like find the best hyperparameters for my model. So that's why we have to use like cross entropy, categorical cross entropy. This is for the loss function for n-class classification problem. And here as an optimizer, I use Adam optimizer. This is the Adam optimizer. And the learning rate is 10 to the 3 into 10 to the power minus 5. So this is the learning rate. So I want to just check the accuracy metrics. So just compile this one and then just use model.pit to run the model. The mini best size is 128 because I found this is the best size, and epoch is 20. I found this one is 20, but in previously in like the code that I took from the Kaggle data set and the GitHub, that was 10, and I just changed it to 20 and found the best accuracy. So this is for the 20 epoch. The final accuracy is 97.1%. So let's have a look to the evaluate the model using test set. This was the training set, training accuracy. This is the test accuracy. So it's almost the same, 97.11. That means there is no overfitting there. And also it will regularize. So there is no gap between training and test accuracy. And this is the plot for the training and testing accuracy and losses function. So you see this is the train model accuracy, and this is the train loss. So it's almost flat. So that means the training goes in a good manner. And then we just have to predict the test data. So this one is for the test data that I have taken as a Excel from the other Kaggle data set, like this one, so this one, and this is the test set. So I just want to check my model with this one to check like whether it is regularized the other model or not. So here you can see. So this is the test data, and predict again and save the Excel as CSV file. So by taking this one, I have to check like whether we have null data or missing data or not. That's why I just check this one and drop the missing data. So if there is any null, that's why I did that, but there is no missing data. That's why it didn't have any use of this code, but in practical case we have to check. So this is the submission CSV file. This is the submission CSV file. Will check like how much it could predict the real data set. Here you can see this is the image ID and this is the class. So predicted class, and save it as a CSV file. So this is the view of my prediction, and then we have to just predict the test also on the same way. So let's have a look to like how my model perform on the other data set, like regularized for other data. So this is the like random 9 plots. See, and this is the predicted as class 7, and it's really labeled as 7. And so here this is the correctly classified data samples, and let's see the wrong classified data sample. This is the boundary condition to check find out the wrong classified data, wrong predicted data. So this is the plot method for to plot the wrongly classified data. So this is the here you can see, so predicted as 2, but originally it's 4. So this is the view. Here you can see this. It looks like 9. It looks like 7, but it shows as like a 9. So this one looks like a 6, but the model find it as a 0. So let's have a look to the task 2. We have to change the optimizer. For this, I took RMS prop as an optimizer, but the last one was Adam optimizer. So this is the RMS prop. The learning rate is same, and also the loss function is the same, categorical cross entropy, and the matrix is accuracy matrix, and the epoch size is also same. and also mini batch size is also same. So just run the test, and we have found 98.38. So it is better than the previous one. I could say the training accuracy is better, and then evaluate the test score on the test data set. So it's 97.94. It is also better than the Adam optimizer. So you can say I found RMS prop optimizer as the best pick for my model. So, and then plot the model accuracy. So this is the model accuracy as usual, same, but it's a straight slope line. So and then I just predict the tests that are similar to the previous one to regularize the my model to the other data set and also check. So the process is almost same. Here you can see this is the predicted, and save it to the CSV file for checking. And also, and then I just did some like a same experiment, like a correctly classified or not. And then I have to check like which are the wrong classified. Right. So here you can see it's predicted as 0, but originally the class is 6. So that's all for today. That's my homework. Thank you, everyone.